Hey, hi everyone. So, welcome back again to our channel TechG Infinity. And as we told that we are coming up with a series on OpenRAN, so let's try to understand the agenda and the topic for today, which is functional splits. And but before that, kindly subscribe to our channel. So, and if you want to connect with us, this is the information what we are sharing. You can connect with us on our mail ID or any mobile number which has been given over there over the screen. Okay, let's coming back towards the agenda of the day, that is functional splits. But before that, as I have told in the last session, that I need to discuss more towards uh, the enhanced CPRI. Let's try to touch the base on that before understanding the functional split. So basically, when you talk from the 5G or ORAN point of view, the enhanced CPRI standard has emerged as a successor towards CPRI, which was defined, for the centralized RAN configuration uh, developed by the ECPRI forum. But when we talk what protocol makes more efficiency towards using the ECPRI is use of bandwidth than its predecessor. So, and the protocol which we are using is packet based. And what does that mean? That means it can be framed with Ethernet. This brings enormous advantages to the front haul network. When I say front haul network, I believe you people are well aware what does front haul network means. This is your front haul network or front haul interface, right? So this brings a good number of advantage in our front haul network, which totally depends upon the functional split that can use the Ethernet connectivity instead of relying on the availability of fiber, which was based out of common public radio interface. So this is what enhanced CPRI talks about. And now let's go back to our agenda of the day, that is functional splits. So what do you understand from functional splits? So when we are describing the functional splits options, so basically this has been described from 3GPP again, and ORAN also came up with its own functional split option, that is 7.2x. So let us try to understand. So functional splits option, operators consider the CUDU as a single logical unit because the split applies to front haul network. Now again, front haul is between DU and RU. They can distribute higher level functions of stack between CUDU over mid-haul network, bit rates and latency requirements between high layer stack functions provide more flexibility on choice of mid-haul transport. In practice, the industry has settled on a split between CU and DU, where CU hosts the network layer functionality, as in RRC and PDCP functionality from the data link layer. Correct? So within the 8, as we will be going towards the architecture or the diagram of functional split, so we have 8 main functional splits options defined by 3GPP, and option 7 further divides into 7.1, 7.2, and 7.3 functional split. So this is what coming from the 3GPP specification. But when we talk from ORAN working groups or ORAN specifications, which will be our next session in this series, which talks about ORAN specification that has been designed by ORAN Alliance. So from there, we are getting the functional split option as 7.2x. So this is ORAN functional split. Apart from that, we have functional splits which are coming from 3GPP specifications. Now we are referring to a very nice prepared document from Haber Schoener, site, and they have given us a very good 5G fundamentals functional splits overview. So if you see this document, you can see this is the split naming overview. First, we need to understand how to read out this particular diagram of functional split. And here I really thank Habashana, and I am giving credit to them to prepare this kind of a document, which is of very useful for all the technocrats who are working in ORAN industry. So let's try to walk through with this document. So basically, as I have already told, that functional split CUDU, we call it as a logical unit, and you can see this is your split naming overview. Again, 3GPP has defined functional splits where you can see 3GPP TR38.801. So we have 8 functional splits which ranges from 1, 2, 3, 4, 5, 6, 7, 3, 7, 2, 7, 1, and 8. So this is what functional splits has been defined by 3GPP. Then we have from ECPRI also ABCD and so on, small cell forum, and NGMN. So we have functional split defined by these entity. We are following what 3GPP has defined, and we call it as high layer split and low layer split, 6 and 7 functional splits. And if you see, there is something called 7.2x, which is ORAN functional split. So this is what ORAN functional split talks about, and you can see this is the split naming overview, and this is the protocol stack, which we have discussed in the last session also, which talks about PDCP IP packets are coming inside, and PDCP is looking into it. And if you see its functional view also, I can zoom in a bit so that you all can understand this properly, how to read the functional splits and its functionalities of the protocol stack. So you can see protocol stack is IP packet is coming inside, and PDCP has to look into it. So what are the functionalities of PDCP? If you see the functional view, this is the data, and coming inside we call it as PDCP SDUs. And once it has, the packet is there, PDCP has to do header compression, ciphering, security part, all these things, and after that it has to add the PDCP header, and then that particular packet has to be sent towards RLC layer, and we call it as RLC SDU. So you can see we have high RLC, low RLC has been distributed, RLC has been distributed, and then we have MAC layer, which is again distributed into high and low MAC, and then we have something called phi layer. And if you see the functionalities, again, RLC, has the functionality of segmentation and concatenation. And when you talk from the MAC point of view, you can see scheduler, multiplexing, HARC, and DL/SCH data transfer. And again, if you see, once the transport block has been prepared, that has to be transferred towards file layer, and then you have CRC attach coding with respect to LDPC if it is PDSCH, or with respect to polar coding if it is PDCCH, or control signaling or control data. And then we have rate matching, we have segmentation before that, because we have base graphs 1 and 2 that we can look into in another session. Then we have rate matching, scrambling, modulation, layer mapping, pre-coding. All these things are processing units of physical layer. So now you can see this is the functionality, and this is how it has been distributed. And now, so what we are trying to achieve from this particular functional split is the CUDU and RU mapping. So this is what we need to understand. So this is what CU and DU mapping, if you see, this is your core network, that we have a back haul, and then CUDU is there, and we have a front haul. If you look into this particular option 8, so this is your option 8, and this line is coming down. This is the functionality of protocol stack layer, and this side this is RF, that means radio unit, correct? So you can see when you are into option 8, you have radio unit where we are having only analog conversion, A to D or D to A or antenna ports, all these things. Correct? So this is what we have in option 8, which is followed in legacy technologies till now. But when we talk, 7.2x, this is ORAN based functionality, or ORAN based functional split option. 7.2x, if you see, beamforming, IFFT, cyclic prefix insertion, and analog conversion relies inside your radio unit, because if you see this purple line coming over here, this is what is your front hall, and you have radio unit which has to look into this functionality and process all these things. So this is your option 7.2x, and CUDU is over here, which is connected to backhaul with the core network. Now if you see this going down, you can see 7.2x and its pros, cons, and use cases. So if you try to zoom in and try to read this out, this is 7.2x simplified interface, open interface protocol specifically designed to enable interoperability between RUs and DUs from different vendor, bitrate scales with MIMO layer, reduced bandwidth requirements compared to split option 7.1, high bandwidth requirement, relatively high latency requirement. These are its cons if you look into this. And this is the use case ideally suited for virtualized RAN and virtualized DU running on general purpose processing platforms. This is what we are trying to achieve in Open RAN. So this is the best use case what we can have, and the functional split that has been followed in ORAN, that is 7.2x. Let's try to understand one more functional split, and then you can follow this sheet to understand more towards functional split. So let us try to understand functional split number 6. So if you see, this line is functional split option 6, which says it is going till here, and whole of the physical layer processing is relying inside your radio unit. That means radio unit is looking for the physical layer processing, and this is what functional split 6 talks about. You can see option 6, right? So here in this, we have front hall over here, and then we have CUDU, and which is connected to your core network using backhaul. Now, what are the pros for functional 6 is bitrate scales with MIMO layers, joint transmission is possible, significant bandwidth reduction, centralized scheduling is possible, allows resource pooling for layers including and above MAC. What are the cons for that? May require subframe level timing interaction between MAC layer and CU and DU and file layers in DU, right? And round trip front haul delay may affect HARC timing and scheduling, right? So this is ideal for small cell deployments, which is being used more towards when you say a use case is private 5G or something like that. So this is where we are using option 6. So this is what this particular functional split overview talks about. Now you can see the latency requirement as you go more towards option 7.2x. We have very tight latency requirement, and if you come towards this side, it is latency tolerant. So when you say option 1, nobody is using that because it is latency tolerant. And when we look into the 5G latency requirements, this talks from 1 ms or below latency requirements when you talk from the 5G point of view. So this is how, when you go this side, it is very tight latency requirement. This is how this talks about. So this is what we have for today when we talk from the functional split overview from the 5G point of view or from the 3GPP point of view. This is how we can say functionality or functional split work. Now, what we are going to cover in our next session is working groups, which talks about, which is ranging from 1 to 11, which is coming from as a ORAN specification. Like we have 3GPP specification, we have something called ORAN specifications that has been produced by ORAN Alliance, and we will be looking into one of one or two of the working group specifications, and we will discuss more about it so that you people can have a good benefit of listening into these sessions. So, this is what we were having from this session. Stay tuned. Please do subscribe to our channel. We provide protocol courses, protocol layer sessions. We provide sessions on ORAN. We provide sessions on 5G technology. So, if you are interested, kindly connect with us on these contacts. Thanks everyone. Do subscribe to our channel. Bye bye.